Hong Kong has a hilly terrain. Most urban areas are along the coastline. The annual rainfall is high, at an average of 2,400 millimeters. During rainstorms, a large amount of runoff flows from upland areas downhill and has to be discharged by underground drains through the coastal urban area to the harbor. Before the completion of urban flood interception and storage schemes, flooding occurred frequently in the coastal urban areas, including the city's commercial center, causing disruptions to the public and resulting in economic losses. In the black rainstorm on the 7th of June 2008, extensive flooding occurred in northern Hong Kong Island, northwest Kowloon and Tsuen Wan, particularly the Admiralty and Central areas. Over the decades, Hong Kong has been developing rapidly. This increases the runoff during rainstorms, in time overloading the existing stormwater drains, leading to frequent flooding. The traditional flood prevention approach requires enlarging or laying new drains amid busy urban roads. This, however, is subject to many problems. Lack of space and conflicts with underground utilities render design and construction extremely difficult. Furthermore, implementing the works in a congested urban environment creates severe inconvenience to the public, disruptions to traffic, as well as adverse impacts to shops at street level. The Drainage Services Department of the Hong Kong government therefore conceived the innovative flood prevention concepts of stormwater interception and storage. Interception utilizes a tunnel located mid-hill, will intercept upstream stormwater effectively. The collected flow will bypass urban strip for coastal discharge. As for stormwater storage, it innovatively utilizes the underground space of urban areas for temporary storage of stormwater so that the existing drainage system is capable of meeting the peak flow. The Hong Kong Urban Flood Interception and Storage Scheme is the largest urban flood control project implemented. It includes the construction of 3 stormwater drainage tunnels and 2 underground stormwater storage tanks. The 3 drainage tunnels are 20 kilometers in total length, with a combined discharge rate of 460 cubic meters per second. They are located in northern Hong Kong, Lai Chi Kok, and Tsuen Wan. The 2 underground stormwater storage tanks have a total capacity of 109,000 cubic meters and are situated in Tai Hang Tung and Sheung Wan. The stormwater drainage tunnels and flood storage tanks complement each other. With these projects, the urban flood protection standard is raised to meet today's requirements of catering for rainstorms of a 50-year return period. The cost of the whole Hong Kong Urban Flood Interception and Storage Scheme is 7 billion Hong Kong dollars. It provides flood protection for the densely populated and commercial areas of Hong Kong. In the planning and design of this innovative project, the Drainage Services Department has brought in many innovative designs and advanced construction technologies, raising the tunnel construction works of Hong Kong to new heights. The Hong Kong West Drainage Tunnel, the longest of the 3 drainage tunnels, comprises some 30 adits constructed by blasting along its 11-kilometer main tunnel. Most of the work fronts are located at heavily trafficked points and narrow streets. Through detailed procedural planning and precise safety assessment, the project team successfully carried out, for the first time in Hong Kong, concurrent blasting of adits with main tunnel excavation within short distances. This significantly shortened the construction period. As for the Lai Chi Kok Drainage Tunnel, it comprises 2 tunnel segments in markedly distinct geologies, one wholly in strong bedrock, while the other in coastal mixed and soft ground. Despite the difference, which will normally necessitate the use of 2 tunnel boring machines of different designs, the 2 tunnels were actually completed using a single, specially designed tunnel boring machine. This not only reduced greatly the materials and resources input, but also constituted significant cost savings. For the tunnel construction in soft and mixed ground, the project team brought in state-of-the-art compressed air technology and a world-renowned overseas expert to develop a meticulous protocol for the works. At the same time, comprehensive medical support and training were provided to the selected personnel involved in hyperbaric operations. This was the first time such high compressed air pressure of up to 4.2 bar was applied in Hong Kong. Thanks to the scrupulous preparation, the works achieved a safety record of 0 decompression illness, which is remarkable for such type of tunneling projects from a global perspective. The works broke new ground for compressed air tunneling in Hong Kong and set new directions for upcoming tunneling projects like the Hong Kong-Zhuhai-Macau Bridge and the Express Rail Link. Protecting the environment is a key mission of the project team alongside achieving flood protection. The intakes of the Tsuen Wan drainage tunnel are situated on natural streams. To ensure a sufficient base flow is maintained to meet ecological needs, the tunnel intakes are designed to start intercepting flows only when the rainfall exceeds the amber rainstorm warning level. As mentioned earlier, the use of a single tunnel boring machine in the Lai Chi Kok drainage tunnel resulted in significant savings in resource and energy input. And for the Hong Kong West drainage tunnel, it adopted the raise boring method to construct many of the drop shafts of intakes. The technique enabled disposal of excavated materials via the tunnel, eliminating the need to handle them on ground level, which greatly reduced noise and dust nuisance and impacts on the surroundings. The drainage tunnels and stormwater storage tanks unavoidably take up some precious urban land resources. The project team strived to make the best use of the land by integrating the drainage facilities with community needs, adding value to this largest flood protection scheme of Hong Kong. The flood storage tank beneath Tai Hang Tung is located at the heart of Kowloon. It is located underneath a soccer pitch, and upon its completion, the sports ground was fully re-provisioned. The associated pumping station is provided with vertical greening to enhance harmony with the adjacent environment. The Sheung Wan's stormwater storage tank is situated at a precious promenade area. After project completion, the ground on top was converted to be a recreational open space, providing an oasis in the busy commercial area. The stilling basin of the Lai Chi Kok drainage tunnel is located underneath the Chingsha Highway. After the works, the maintenance areas on top of the basin and its environs are converted into a sizable pet garden for public use. The land thus serves concurrent triplicate purposes of drainage, transportation, and amenity. What's more, rainwater collected by the drainage tunnel is utilized for irrigation, toilet flushing, and street cleansing, conserving precious water resources. These initiatives well illustrated the project team's commitment towards sustainable development. Progressive commissioning of the flood interception and storage works saw a marked improvement in drainage performance. On the 22nd of May 2013, a black rainstorm struck, resulting in torrential rainfall across extensive areas of Hong Kong. Despite this, no notable flooding occurred in the urban areas, attesting to the effectiveness of the flood interception and storage scheme. Driven by an endeavor to continuously better its services, the Drainage Services Department achieved a number of technological breakthroughs and engineering advancement in the Urban Flood Interception and Storage project. Indeed, the project has gained wide recognition in a number of international and local awards for its innovation and efficacy in combating flood risks. Looking ahead, the Drainage Services Department is proceeding with the construction of a stormwater storage tank under the Happy Valley Racecourse and Recreational Ground to resolve the flooding problem in Happy Valley. The project team adopted an automatic movable weir coupled with real-time monitoring of water levels to control water intake and discharge. To optimize the weir setting, they applied computational fluid dynamic modeling in the design process. This innovative design culminated in a reduction of the required tank volume and depth by 1/3, and with corresponding energy savings in emptying the storage tank after rainstorms. Building on the success of the Urban Flood Interception and Storage Scheme, the Hong Kong Drainage Services Department will continue its endeavor to provide flood protection services meeting community needs through innovation, land saving, and sustainable development principles.